Hi there, my name is Lawrence Reggie Redil, and this video presentation is about the thesis entitled On the Egg Drop Numbers. This paper is an exposition of Michael Boardman's journal article, The Egg Drop Numbers, which was published in Mathematics Magazine, Volume 77, Number 5, back in December 2004. Well, this exposition focuses on dropping of eggs at a particular story of a building and on providing a way of calculating the egg drop numbers. Here are the list of notations used in exposing the paper. Before we obtain the main result, we need to answer first the following problems. SOP 1. What is an egg dropping experiment? An egg dropping experiment is an experiment at which some eggs are given to conduct a test at which floor it will break or not upon landing. With that egg dropping experiment, Boardman was able to come up with an original egg drop problem. We wish to know which windows in a 36-story building are safe to drop eggs from, and which are high enough to cause the eggs to break on landing. Suppose 2 eggs are available. What is the least number of egg droppings that is guaranteed to work in all cases? Boardman formulated some simplifying assumptions to make it mathematical. Those assumptions include broken eggs can no longer be used, while eggs that are not broken can be reused. Eggs will be broken at higher floors given that it breaks at a particular floor. On the other hand, eggs will survive at the lower floors given that it survived from a particular floor. 2-egg problem. This diagram illustrates a table wherein the first egg was dropped from the 8th floor. And if this egg breaks, you will go back down to the first floor and work way up until the second egg breaks, unless it survives the drop from the 7th floor, in which case there is no need to drop it from the 8th. If the first egg does not break, move to the 15th floor and repeat the process. The first column pertains to the first egg that was dropped, and the second column pertains to the second egg if first egg breaks. With the original egg drop problem and the 2-egg problem, Boardman was able to come up with another problem, which is the generalized egg drop problem. Given k eggs, how many floors can we reach if we have at most n drops? The answer to the generalized egg drop problem yields the answer to our SOP2, wherein we need to define the egg drop numbers resulting to that experiment. Egg drop numbers pertains to the number of floors that we can reach given a particular number of eggs and having at most number of drops. It is denoted by the below symbol, which is read as n drop k. SOP 3. What are the different approaches in estimation of the egg drop numbers in an egg dropping experiment? For us to estimate the egg drop numbers, the different approaches we need to use is by recurrence relation and generating function. SOP 4. How is the height of the floor at which an egg will break from dropping estimated by using generating functions and recurrence relation? Egg drop numbers by using recurrence relation. With the above figure, we will have the recurrence relation which is equivalent to n-1 drop k, where it pertains to the top part of the figure, where the egg survives, plus n-1 drop k minus 1, where it pertains to the bottom part of the figure, where the egg breaks, plus 1, where it pertains to our initial drop. Egg drop numbers by generating function. The generating function for the sequence of egg drop numbers is the function g sub n of x is equal to the summation of n drop k x raised to k, where k runs from 1 to infinity. This is also the same as the expression below. Lemma 4.3.1. The summation of n minus 1 drop k minus 1 x raised to k, where k runs from 1 to infinity, is equal to x g sub n minus 1 of x. Lemma 4.3.2. For each n greater than or equal to 1, g sub n of x is equal to 1 plus x, g sub n minus 1 of x plus g sub 1 of x. Lemma 4.3.3. For each n greater than or equal to 1, g sub n of x is equal to 1 plus x raised to n minus 1 all over 1 minus x. Considering the lemmas shown earlier, we are now able to obtain the final result, wherein it's in the theorem 4.2.2, wherein for all n and k greater than or equal to 1, n drop k is equal to the summation of n taken j, where j runs from 1 to k. Conclusions and recommendations. The generalized egg drop problem. Given k eggs, how many floors can we reach if we have at most n drops? The answer to that question defines the egg drop numbers, the numbers of floors that can be reached having at most n drops, given k eggs. Egg drop numbers is labeled as n drop k. The ways on estimating the egg drop numbers are by the aid of recurrence relation and generating function, wherein we yield the final result or the final theorem, which is for all n greater than or equal to 1 and k greater than or equal to 1, we have egg drop numbers equal to the summation of n taken j, where j runs from 1 to k. For the recommendations of the paper, are there any other special types of numbers that can be determined using generating function? Second, are there any other ways in how we can calculate the egg drop numbers? And lastly, is there another formula on finding the least number of eggs instead of the least number of droppings and number of floors?